Hello, good day. I am Topman Paul-Dike. Welcome to section 3 of the Simple Shell series. And these are the outlines, and we've gone far. We've actually gone far, about half, and today we'll go more than half. Okay, about half, right? Not exactly half. And so, I encourage you, if you've not seen the other part of this series, you need to see it so that you don't get confused here because I'm going to avoid unnecessary repetitions. So to help me so that I'll move faster, um, go to my YouTube channel. On the home page, you will see a playlist named Simple Shell in C. Or better still, you can click on playlist and then my playlist will appear. You will see Simple Shell in C. So when you click on it, you will see the previous videos. As at this time is only one, two, because this one is the third one, right? So so it is updated as often as we make take new sections, and um, so it's important you watch it so you don't get lost, okay? And don't forget to subscribe. It's very important. Um, you can follow me on GitHub, on LinkedIn, on Twitter. I mean the username is the same, T Paul-Dike, alright? Okay, so far we've done introduction, we've talked about PID and PPID, we've talked about arguments and command line arguments, we've used all these functions. This prototype we've used it, we've used these functions, we've learned how it worked, right? Basically. But I want us to get to the point where we get to use it, you know, and do right a simple shell actually. Yes. And so we've not done this, but my plan for this section is to work to clarify this because I've already done something about this, right? Creating processes, and so I think it's better we talk about weight as well, which is the system call for suspending processes. So I'm going to cut this from here and have it after this one because that's actually the order I happen to have followed. Okay, so now let's go to the task or the objective for this particular section. Please, if you have any question, feel free to ask. Yeah, you can ask if you're watching live right now. I will respond. If you're watching later on YouTube, no problem. You can as well post your question as a comment, and I will respond as well. So today we're going to talk about. I'm going to introduce you to the PS command. We're going to talk about Orphan process. We're going to talk about zombie process, and then the need for wait, how wait works, and then maybe I will add SZV. Yeah, we'll talk about it as well. You're making progress. We're making progress. So let's talk about PS command. Before I do that, let me show you something. Let me show you something. You know, so that thing you're seeing is not really my computer. This is my computer now. Interesting, right? So what you're seeing, what you have been seeing me work with. I mean, this is um, the terminal on my computer. What it looks like. So you can see it's not my computer I've been using. Actually, I'm using a computer. I'm using some computers inside my computer. I'm using some virtual machines, and so this is the virtual box. You can see I have two virtual machines running. So it's like I have two computers inside my computer, right? So this is Ubuntu 22.0 for. I click show. What's this? Okay, reload. Then you can see, right? So and then back to the virtual box. This is Linux Mint. Alright, if I click show, the one I'm actually using now. Alright, so this is me. I like to play with codes, right? So I don't want to be careful. I don't want to be careful when I'm coding. That's why I come to this environment because I can just think, if I do this thing like this, what will happen? If I do this like this, what will go wrong? I can crash the system and install another one. So it's not my own computer. You know, nothing. It's not what I'm doing here is not affecting my computer, except that it is using some space in my computer. I allocated some space to it. You know, the amount of RAM it should use, and the amount of storage space it should use. Okay. I'm even thinking of teaching how to do that, but there are videos on YouTube that teaches how to install virtual machine. So you can play with your sandbox, you can play with a virtual environment, do system calls, see what happens, you know. So this kind of program is not a program you should write in your own computer directly, because if you make mistake, that's a mistake that are too costly. Alright, that's just by the way. So PS command, how does it work? I'm going to call up my terminal. Let's play. Let's play. There's a command called PS. What it does is to show us um, the processes that are running. Okay, so yeah, you can see that bash is running, and I think I should hold on. Let me have this like this. All right. So it's necessary. Formerly I used to use two tabs, but right now I'm using two windows. There are two windows I'm using, and it's necessary because the command, the today's section will be such that we will monitor what is happening on one terminal with the other terminal. So it's important. And so if I do PS right now, it shows me that a process with process ID 4454 is running, and the name of that process is bash. And another process with 6215 was running at the time, which is this PS, the same command, that ran. If I do it again, of course, you know that this thing will be the same. If I do it here, PS, so you see, we now have this here. But let's confirm whether is so, because the process is still running, right? The bash is still running, so you can see that it's 3830. If I do the same thing here, echo $, you see that it's 4454. So everything is working. So if I want to be able to check everything that has happened, everything running right now, everything running right now, from the very first one that started to the very last one, and the last one will always be the commander and the last commander entered. If I pass this option to it, EAF. Now this E and the A makes it select all process, right? This A is actually invoking the BSD style. I didn't plan to do too much explanation, but let me use that word, BSD. I'll duplicate this. BSD style, like Mac OS, right? BSD stands for, I hope I'm not mistaken, Berkeley. Is it Berkeley? I don't know whether I'm very correct, but that's what I think it stands for. Berkeley software distribution. Am I correct? You find out and post this on the comment section if if I'm wrong. If you have the correct one, post it. So it's a standard, right? So when I pass that option, I'm saying, hey, give me in this format, right? Give me everything, like all processes that are running, including ones that are running in the background, and then the F stands for formatted listing, like full format. I want it in full format. Another option that I could pass, I just introduced what PS does, and I just showed you today about what it does when this particular option is passed to it. Let's enter it and see what happens. So it prints the process table. Let me make this. I hope you can see. This is large enough, right? Let me see if I can make it larger. Supposed to zoom in. Okay, this is better, I believe. Where is the other terminal? I'll zoom in a bit as well. All right. Now it's listing the process table, right? And this is like this is telling us everything running here from the very first one that ran. The things they are still running, right? These things are still on. It does not list dead processes. It does not list processes that have stopped. The reason it listed this one is because at the time it was listing it, this one was running. But of course, this one ran in 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 smaller split of seconds per second. For it, it ran so fast, right? And so um, here we see. Okay, I think we'll talk about this later. But observe that this column is named UID, unique identifier, right? It looks like user ID because we are seeing root. All the users, not just me now. I'm logged in as Paul-Dike, not just me. I'm not the only one showing. All users are showing, and then the PID, process ID, is showing. The PPID, the parent. So you can see that this guy is the boss. He does not have any parent. He has a PID of 1, and that process is called the edit process. This is the very first process that runs when you own your computer system, right? Another one like it, but not exactly like it, is the one with the process ID of 2. It does not have any parent as well. It does not have a parent. It's a boss on itself, and you can see that these two gave birth to several processes. If you scroll down, you find that one, the process with the PID of 1 gave birth to a few more processes here. And not even few, there are plenty. Woo, big pros. Alright, so you see the table such that you see the parent that gave birth to, like this. Look at here now. You see that 502 gave birth to the process with ID 544. So this 502, you find it somewhere here. Look at it. And we're talking about this. So this place will be listing the command. CMD, you can see it. CMD, list the command. That's by the way. Now let's look at another option. If I do PS hyphen AUX, what I'm saying is, okay, let me clear the screen. Okay, what I'm saying is, hey, list all processes, from all users, right? And I'm saying give me detailed information. That's what this U is doing. You give me detailed information. And I'm saying add background processes, this X. That means there are background processes. Are you aware that I could be running, like, let's say for example, you may have seen me do this before. I'll come back to this. Let me take it off first. Let me use the VI. I don't have VI installed here. I've shown you. Now, if you're in VI, if you use VI, why VI is open? If you press Ctrl Z, right? That may mean Command Z for some of you. Ctrl Z. It will. It's like you minimizing it. It will minimize. But the actual thing that happens is that it's still running in the background. So it's still open, but in the background, it will disappear from your terminal. So if you type FG and press enter, it will appear again. Right? FG is for foreground. So when that X option here is saying call the one that is not running in the one that is not running in the foreground as well, the one that's running in the background. List them out, and the ones that are running in the foreground will have a symbol like this plus added to them, to their status, right? Let's press enter now. If what I'm explaining is sounding strange, don't worry. You can see that I have more fields here, I have more columns. It is more detailed because it has instruction to be detailed. You can see it's telling me, giving us more. Now I know about a few of these things. R means running, S means sleeping, D is uninterrupted sleep or something. The small S means I think lead. Is it leading program? Something leader. something like that. Now look at that plus. That plus means this one is running in the foreground. It's running in the foreground right now. This one is sleeping and it's running in the foreground. Sorry, yeah, in the foreground. Yes, that's correct. Let me show you these interesting two processes that are running here. Remember this PID 3830 4454. You are seeing how accurate the information is. So it's telling you that the same process gave birth to them. 11268. 11268. It means that when you call forth a terminal, it is this guy. Where is it? 11268. Let's look for it. That's the guy that call forth the terminal for you, that brings it up and make bash, actually not just the terminal, sorry, the bash program. So this guy is the guy. No, am I correct? Hold on, that's commands, doesn't look like it. Back to bash. Where are you? 11268. So it shouldn't be 11268. 11268. 11268. Where are you? Appear. 11268. 11. I can't. Okay, it should be up, right? I can't find it. Come on. Is it that he called the process and disappeared? Alright, that's by the way. But basically that's what happens, right? When I want to get more information, especially about this one, because I will be interested in the status. You can see at the top of the column is the header start. So when this is the main that's making me come for it, not today's date. Okay. Let me clear the screen now and take it back to the right, and let's experiment and see whether this guy will really show us what is happening. So I'm going to run a common command that we know, sudo apt update. Let's see whether it tells us that update is running. So update is asking for my sudo password, and I'm going to supply it. Alright, so it's running. Now let's do ps-eaf. Go. Now I'm gonna enlarge the screen so you see it very well. Stop misbehaving and obey me. Come on. So look at it here. Sudo apt. Now watch something interesting. Watch. So it's showing that as a parent, how do I explain this? Follow me closely. Don't worry, first follow me closely. It's showing that two of these processes are running. Remember I told you about child processes, right? PPID and PID. This guy is running. Remember 3830 is the process ID. Sorry, is the process ID of that bash running on the terminal on my left hand side, the one that is running it now. That guy went and gave birth to another guy. He didn't run it by himself. He gave birth to another guy, and this guy as well that he gave birth to went and gave birth to another guy. So this guy gave birth to this guy. I think you're seeing the relationship. They are also giving back, and at the end of the day, watch out. If I do this thing again now, all these children, let's see what children will be here again. When the process is true. Okay, it's true right now. Watch, observe these guys. Observe from here. And I'll tell you something about it. Observe what will be the last now. That I won't clear the screen for that. So let me just do it again. So you see now that we don't have from where they started giving those bets, we don't have them again. Only have the guy standing here alone. 3830. Let's scroll up to the other one and compare again. Let's scroll up. Don't worry, don't be confused. When this matter started, a process was given birth to here by the bash that was running. and that process gave birth to another batch. It means for everything that wants to happen there, they will be giving birth, giving birth, giving birth, giving birth, giving birth, and they kept this one even gave birth to two processes, 6445, right? And then at the end of the day, this is entirely different. This is the command that I entered, so this is different. Now at the end of the day, when this child finish executing, it will return to these parents, and the parents will take it off from here. It's the parents that clears the child away from the table. It takes the child away from the table. The technical term is to rip off, rip off. So it rips this child off. Then, since it's the parents of these two, it will rip them off. Oh, it's the parents of three, four. Interesting. It rip them all off and return to its parent. Its own parent now will rip it off, and this its own parent return to the parent again. It will continue that way until it gets to this guy. This guy will take them all off and still stay there. Remember, this is a bash itself, and it will loop forever. It will loop forever. What do I mean by that? I'm going to clear the screen. This thing you're seeing here is a prompt, and it's a loop. It's looping. So no matter what you enter here, it will keep looping. Enter rubbish, enter what makes sense, it will keep looping forever until it gets the EOF signal. Until you kill the process, until you end the process, it will continue looping. This is why it becomes important. I think you should get it by now, that you're expected to write something that works like bash, something that's able to print a loop and will not stop printing that loop. And you give it something. The only way it will not stop printing that loop is that when you give it something, it will not go and do that thing you give it. It will pass it to another child. It will give birth to a child and pass that thing you gave to it, that command, to the child. The child will not be the one to execute the command and die, and come back to him, the parents, or to her. I behave like women, so it's her, it's she. Okay, let's make progress. Back to our whiteboard for now. Okay, I also introduced the command PSAUX. Alright, so orphan process, zombie processes. Why did I add the question mark here? Orphan processes, zombie processes. Okay, orphan process will do. Zombie process. What is an orphan process? Excuse me. What is zombie process? Let's go back to this place where I told you that whenever the fork system call is made, it creates an identical process from that very point where it is created. I think we should start writing code now. What do you think? And I would like to write codes on Ubuntu, not on Linux, meant I don't want their problem. So let's go to Ubuntu. Okay, and I was trying to illustrate something here. So I'm going to call for the terminal, and I'll make it full for now. I will call for the second one when I want to monitor it. So let's make this. Where is that option again? Okay. Larger. Is this large enough? No, this is too much. Okay. Let's move into the repository and create section 3 and cd into section 3. All right, is there a code we can copy? I think we should write afresh. So if I go, I'm using Nano, right? If you've been following this section, I've explained why I'm using Nano. It's just one of the editors. It's just a text editor, like a VI or Emacs or VS Code, whichever one. But yeah, I'm a command line person. I like command line, and most of the persons that follow me are command line, especially ALX students. So I want to create. Let's call this one process.c. So I'll go Okay, so let's just do this. Okay, I think carry on the return statement here. Okay. Reminds me, excuse me please. This phone must not ring now. Don't ring again until June. Okay. So if I put an instruction here and say print f, come on, what am I doing? Print f hello, yes, I had a new line. Let me put another instruction to print f 2 plus, okay, let me 2, there's, or let's say is 4. 4. I want a new line, of course. Okay. I want you to understand this very well. Now to make the fork system call, remember from the manual we discovered that we need to include 2 headers. Alright, so we need to include if I'm not mistaken 6 / types.h. I also need to include uni std, right? .h. I hope I'm correct. Let me confirm. I think I want to create another terminal, a new window, because this time we're not working with tabs. It's windows now, so make it large, and then now we do man this. So I'm correct, right? These are the 2 things you include, right? Okay, we're making progress. Now, having included that, I can now call the program here. So if I call this program here, the points that will be duplicated is this point. If I call it up here, if I call it up here, it will create a child process at this point. You can even create a child process inside a child process, instead, like I showed you now. I showed, like when we did sudo apt update, it was creating child process inside child process. So there were grandchildren, in the process. So you just think only your bash is doing the work. It's like bash refusing to die. So anyone that will require running the command and dying, or running the command and I'm not using the word dying. I think that's what we're explaining well. Run the command and die. Anyone that requires running the command and dying, it will not take it. It will create a child that will go and die that death. Run the command and die the death. Come back to me. I am still here. You need to understand this. Now, if I run this file, save it. I like to use this other terminal to run the file. So I'll take it to my right. I will exit this manual. I will compile this file. I will name it process. So it compiled that error. Let's run it now. So it says, let me make it full screen. The first one run. One of them, either the child or the parents, right? Printed first. And of course, well, how will you tell which one is the parent? And how will you tell which one is the child? Now watch this. This was the let me demonstrate this on the whiteboard. Okay, so we had a program like this, and a program like this. All right. Okay. So from this point where you call this thing, it will create an exact type of the program, but that program will not have all of these instructions that are here. It will begin from here. That is to say, if I had called this thing, um, if I had called it here, if I had done something like this, it will create an analytical process that has all of this whole instruction, this entire instruction. So it will create a child with this exact instruction, and so the child will not do the two things. Let's just do that. Let's try that now. uh, where is that editor? So I'm gonna move this from here and have it pasted here. No, that's the wrong place. What's undo again? All right. So I'm gonna save it, go back to this terminal, compile it again. Now I'm gonna clear this terminal and run it again. So you can see now it's not carrying out the two instructions because of the position where that function was called, where that system call was made, right? Because that's what we have on the whiteboard right now. It will just happen. But when this happens, right, what we are supposed to expect is that this guy will execute, right, run and get to this point, and then return to the parents. This is what we expect to happen, and then the parents will now continue and run to the end of the program. Now, but this is not always what happens. Now, there are two things that are likely to happen. Let's illustrate them. There are two things, you know, that are likely to happen. Let me use test. So one of the things that are likely to happen is that this test is too big. I think I will duplicate this or replicate this one and edit it. So it's either the parent waits for the child, or both will run concurrently. That's the word I like to use, concurrently. So let me add or here. Alright, so for the parent process to wait for the child process, it doesn't just happen, okay? It doesn't just happen. We make it happen. And for both to run concurrently is actually dangerous. And that's where orphan process and zombie process comes from or happens. Because if the child runs, if this child, if both run concurrently, it's either the child will finish before the parent or the parent will finish before the child. The child will either finish before the parent or the parents will finish before the child. I did that in the last section before I ended, as I was going to explain. Now, if the child finishes before the parents, okay, let's start from the parent. If the parent finishes before the child, that's what we refer to as zombie state. zombie because the sorry, orphan state. Follow me closely. I refuse to confuse you. If the parent finishes before the child, that's what I'm saying, right? Parents before child. Let me put it down just so I don't confuse anybody. Um, I'll just add it to this place. I'll take this and put it like this. Okay, I think I don't need this actually. Just go and add it here. So the parents, so let's say stops, finishes before child. Okay, it's fine. Before child. Of course, when I say parent is child, I mean parent process and child process. Okay, it shouldn't be confusing. Uh, so for the zombie process, it is a child finishing. I say when the child finishes before parents, or I think the most accurate thing to say is that it finishes while parent is still in process or in progress, or while parents is still running. That's better. Okay, so let me now complete the grammar. Let me complete the grammar even if it spans to the next line. So I will say parent process, when parent process finishes before the child process, and then this one is when the child process finishes while the parent is still running. I hope this is not maybe I should format it like this so that this description takes a new line, and also this description here takes a new line. Okay, I think I'm making progress. That's it. Alright, so now you start getting now. Why do we avoid this thing? Let me explain in codes what this means first of all, right? Because this child, when the child process is created, is either using resources from the parents or directly from the operating system. Now, if that sounds strange, don't worry as well. Don't worry. Don't don't expect to watch this video once and get everything on it in it. You know, don't expect to. Me, I'm trying to compress into a few hours. What took me? What took me? I don't know. I don't know how long it took me to learn this. It took me so much time. So when I compress them into 1 hour, eh, it's normal for you to watch it more than once to get it. You know, to if you understand what I'm talking. Okay. So, but if you really want to learn, you will do it. You will do it. You will read documents. You will learn. You will watch. Okay. Several persons are teaching these things, and some of them will teach and not get to the end. Some of them will explain some functions and not get to the end. Some of them are, are just going to waste time, just looking for how to get view. And I wonder how they are able to get viewers, get view. So some persons get tired, like this is simple. Should be like, I've seen this thing every time. I've seen all these things. You that is watching now, I've seen that. Okay, so I can really watch and learn. I sought for such opportunities and I didn't have. I didn't have. So you that is watching, be diligent enough to give it what it takes. And you can do it. You can do it. If I journey from newbie to this point in a matter of months, then you can do it as well. Yes, you can. You can. Let's make progress. Now let me demonstrate in code what I mean by orphan process, what I mean by zombie process. Now, these two processes now, how do we know the one that is the child and the one that is the parent? It's when we save their PID, right? I've explained that in previous videos, so I don't want to start explaining again. So if I do declare a variable of type PIDT and I call it PID and I say it should save the return value of this guy, so that way we are able to check which one is the parents and which one is the child, right? So let me take off this thing. Let me modify the program that I wrote. But the first check that is very necessary is to check whether it worked based on its return value, right? It returns a negative value, negative value if it fails. It returns 0 if it succeeds, right? No, it returns 0 in the parents and return a positive number, right? What do I mean? I'm saying when it has finished, it has an instruction to return 0, right? When it has finished, in fact, that's this guy, that's the instruction. The instruction is from this guy, not this one I put here. It will return 0 to the parent, right? It will return 0 in the parent. Then when it's on success, it has a PID. That PID is not a positive value. Am I correct? I think I'm correct. Then if it fails, it returns negative value, -1. Check the manual to confirm. So we're going to check whether the return value is -1. So we'll say if what the variable PID caught was -1, we know that it failed, right? So we'll come here and instruct it to tell us that it failed. And it should stop the program. So ask it to return. And I have to give it -1. Okay. So that means our program should stop there. Okay, but then if it succeeds, right? How do we know if it succeeds? If it's equal to 0, if that guy, let's say S, if PID is equal to 0, this means it's in the parent now. It's in the parent now. We're not ask it to do something, right? Let's say let's how do we do this now? Let's say return. Don't do anything. Just return. And let me just show you something. Then else do this. By stating this condition now, only the child process will run this thing. I've not done anything too complex here, right? I'm saying if it failed, print this and stop. If it did not fail, check whether the PID is equal to 0. Then if that's the matter, it's inside the parents. Stop. Otherwise, if it's not equal to 0 and it's not equal to this, that means it's a positive value, right? Then this code should run. Let's see what happens here. Let's see what happens. Okay, we will compile that file again. The compile that error, will run it now. Alright, so it print only 1. So it's the child that is printing this thing now. It is a child. If you still want to confirm, let's go and add something just to be very sure. Let's go and add a print statement here and say printf I am the parent on a new line. I'm taking it bit by bit, right? And let's have, I'm going to copy this, have it yanked here. So this one will be I am the child. Okay, so I'll save it. I'll go back here, I'll compile it again, and I'll run it again. Interesting. Okay, what is happening here is that they are actually running together. So this guy is running first, and this guy ran. This guy intercepted because they're running together at the same time, and then this guy continued. Let me confirm by making one to sleep. So let's make, which are we going to make to sleep now? Let's make the parent sleep and confirm. So mommy, sleep for 2 seconds. That's enough time for the child to finish running, right? I like playing with codes, I told you. Let's run again. You can see. So the guy has, since we're ready to sleep now, he didn't come to intercept. Before he came and because he was running as though they are doing competition, he came at the center and did his own. So we've ready to sleep. You can see he came here. Okay. Like I tell you, I like playing with codes. Now let's explain orphan process and zombie process. Don't worry, you will learn. I'm going to take off this printf. I used to print something else. Let's say, okay, let me just I'll just have it pasted here, and I will go up here and declare 2 variables of type PIDT. I'll declare PID and PPID. That of course means that I should take this off because I won't declare the variable twice. So it's the same variable declared up there that's being used. Let's say, okay, let me even declare another one. Okay, that PID was not the accurate name for this guy. Seriously. Let me call it val for value. It was not accurate because he was not returning PID. It was not returning PID. So I'll correct this to P to val and val. Okay, now I want to get PID. What and what do we need to use to get PID function? I think they are already here. Let's try. If it's not here, we'll add. We need to add. Yeah, that will add. I hope this thing is flowing. Follow me closely. Don't worry. Now I'm creating the chat process here, and I'm checking whether it failed here, and I will go here. We need to use sleep. Yes, we need to use sleep. So I will say I am the parent. My PID is, let's do percentage U, and just not to confuse you, let me save it inside this variable. I will now say here, I will say PID equals, I'll call the get PID function. Yeah. Then I'll go PPID equals get PPID. It's getting complex, right? But you follow from the beginning. You should be enjoying yourself. So my PID is this, and I go and say my PPID. So print one more. Print F. My, let's say parent PID is %u. I was using %i the other time, right? I think this is the most accurate to use. Well, %i will accumulate integers of negative values, but this one is strictly for positive values, unsigned integers, right? So I think it's the most accurate to use. %i will still work anyways. But you don't want to mess with the checkers. Alright, are we good to go? And I don't want to have this return value here anymore, since it's something they have in common. Okay. So let's go. I will take this off, and I will do the same thing here. I wish I can. I wish I could just copy all of this and have it pasted here. Yes, I can. Cut into that program for me. So let's grab this. Okay. I want to paste that. Here. Alright, well, I am the child to replace I'm the parent, so I will go here, cut this from here, paste it here, and move it, indent it, and I will take off I am the parent, and everything is fine, right? But we won't let them sleep for the same time. Okay, so we want to see what happens when the parents terminate first, right? So we will delay the. I like to delay the boot process. So let's delay this by 10 seconds. So I can have enough time to explain. And let me delay this by 30 seconds. 30 seconds. Now I'm going to use the grep command so that we don't fill the place with table. What I mean by the grep command is this particular command that we call grep. Okay, let me add it to this one. Grep. What grep does is grep filters, right? Grep filters what you want. So we'll say grep and we'll tell it what we want it to filter out, and to filter it out, right? It will search for patterns. Searches for pattern. So grep, what I mean is this. Remember how that if I run ps EAF, it gives me this, right? Now what if I don't want to display this table, so I don't get confused? I want to take only the one that has to do with bash. So I can say ps and say and pipe this command into it to say filter for me anything that has a string bash. So let me clear the screen. If I run that now, you can see it just went and took only the ones that has bash. Right, so I'm going to be using it so that you don't get confused. Right, okay. All right, it's time to do some magic. I'm going to close this terminal. Let me look at the program again whether it's working well. We are delaying the parents. We want to create an orphan process. I'm going to show you live and direct what is orphan process. The term is serious, right? It's a serious term, it's not a joke. I didn't make it up. I learned it. Thank God for the likes of Jesse from Jesse's Bed. one big inspiration I've had. All right, this time I want to run the program this way, and I will compile. Okay, let me take it to the. You understand that both terminals are accessing the same computer, so there's no big deal here. But let me compile it again from here since I've used the command here. So you compile the error, clear this screen. Don't confuse anybody. Clear this screen as well. I would like to make this thing, what's happening in the background, come on. So I'd like to, can't you just relax? It's okay. Let's manage it like this. Let's manage it. I'd like to make this one smaller because that process table is capable of covering everywhere. So let's clear it again. Fine. So I'll create my process table here. I'll run the program here. Ready? First one is delaying for 10 seconds, so it's enough time. But let me type the command and keep it. px. Are you ready for this? Let me use EAF because I want to be able to tell who the parent is and who the child is. What I mean is this. Let me filter bash process and show you. So the reason why I'm using this one is because you recall that this is the PID, this is the PPID. It reflects, it shows us the PID and the PPID. So I want this information. That's why this is enough for me. This is enough for us to illustrate Orphan process. That's why I'm going for it. But this time I'm going to filter, not bash now. I'm going to filter anything running that has the word process. And you know the file you're running has the word process. Ready? Let's go. Bam. 10 seconds. I print. Yeah. That's what happens. It says, look at what is happening. Don't worry. When the child executes, child has execute. So I'll do it again. Waiting for it to complete. And let's check out what happened. I'll do it one more time. Okay, so it was the parent that executed. Sorry, the parent has finished executing, the child has not executed. Now let's see what happened. I did it three times, right? That was intentional. First of all, let's go and find out what is the parent. The very parent of this guy. Echo $$ tells us that the parent is 8598. The other one I was in Linux Mint when I was getting the, so don't be confused, right? I was Linux Mint that time. I just came back to Ubuntu. We've not checked this one before here. So it is 8598, right? This guy says I am the parent. My PID is 9516. My parent PID is 95150. No. Something is wrong. I think I'm reversing the process because this one is actually the parent now. Something I'm getting wrong. This is the parent because it has, the parent is this, and this one is the parent of this one. Okay, so there's something not right with my code. Hold on, please. Let me fix it. Nano process.c. So if is 0, do this. It's a positive value. Do this. Okay. It returns its PID. So this is actually the child. This is actually the parent, rather, and this is the child. Okay. Let's find out by reading the manner. Okay, let's be sure. So man, let me clear this. Man get PID. Is that? No, this one. Alright, let's look for the return value. So return value on success, the PID of the child is returned in the parent, so I'm the one making the mistake. Okay, and 0 is returned in the child, so 0 is returned inside the child. I'm making mistake, sorry about that. So it is inside the child that 0 is returned, so it is 0 that we used to know that it is the child, right? When is a positive value, when is the PID, know that it is the parent, because the PID is returned inside the parent, while 0 is returned in the child. Meanwhile on failure, it returns -1. So read the manner, come on, read that funny manner. Alright, so now let me correct my code, please. Let me correct my code. So this is actually the child, not the parents. This is actually the child. So we want to create an orphan process, so it is the child that we should make to sleep for, let's make it sleep for, let me say 10 seconds. We'll be faster this time. And let's make the parent sleep for 5 seconds. That's enough time. And so this is the parent. I am the parent. That sleep, I just wanted for me to catch the state while you're sleeping. All right. Watch this closely. I'm going to exit again and take it back to where it was and clear the screen and compile the program again. So I'll go gcc process.c compile and produce process at output. It worked, no issue. Remember, echo $. 8951. So let me put the command here, so I'll be able to delete. This is it, right? ps-eaf filter things that have processes that have the string process. All right, now let's run it. Process. So within 5 seconds, I will run this command. When the parent finish, I will run the command again. Okay. Now watch. Let's deal with this. So, it says I am the parent. My PID is 9637, and my parent's PID is 8598, which is correct. And then the child says I am the child. My PID is 9638, right? And my parent is 9637, which is correct. Let's come to this table. On this table, there was a process with the process ID 9637 running, which was this, and the parent was 8598, which is this, right? And then there was another process running 9638, which is this one, and the parent was 9637, which is still this parent. Now, when that parent finished executing and left the child, when the child came back, look at this. The child is still the one with 9638, right? The parent changed. How come? The parents changed. This particular last one, don't mind this last row, right? This last row is the command I entered, so we're not concerned with it. You're concerned with the first 2 rows. How come? What happened here? Now this is how my own operating system here in this particular virtual machine, it is Ubuntu 22.04.02, chose to handle it. Some operating system will use a different approach. Nobody. So what happened is that this guy came back, this child came back and could not find its parents again. Meanwhile, he's supposed to return to its parents. So when you make that return 0, it's supposed to return to his parents. Like you finish executing, go back to your parents. It came back, and the parent has finished. and it did not see the parent again. And I just showed you a moment ago that it is the parent that rips the child off the process table. So the child has finished its work. It is supposed to be ripped off the process table. So it's looking for a parent to help it do that. It didn't find a parent, so it started going, looking. I don't have a parent. I don't have a parent. I said they are behaving like women. So who will breastfeed me now? Don't mind me. I was so it started going, but seriously, the child started going back, top to the top, asking for a parent, until a parent adopted it. I will show you the parent that adopted it by removing this thing. I will remove this filter and print the whole table. Remember, the PID is 1389. 1389, right? 1389. So I go. Let's look at 1389. Look at it. Look at the guy that adopted it. This is how my operating system handles it, right? Your own may not be able to handle it like this. And this guy is the direct son of the init, the Baba, the point one. Direct child of the init. If this guy had not adopted it, it would have run straight to this one by going straight to this table. Because if all the parents here reject it, this one will not reject it. It will not have a parent PID of 1. But in our case, it was able to be adopted by this kind parent here. I think it was, just remember, 136. I don't remember again. But that's what we call orphan process. It became an orphan. So it looked for his parents. He could not see his parents. And this guy too, that is supposed to be the grandfather, did not. This one rejected him. I'm talking about process 8598. That is it. Should be one of these batch processes. Okay, look at it. 8598. 8598 refused to adopt it, and the parent of 8598, which is 8580, the father of both batch that are running, or the parent rather, refused to adopt. So it kept going up. Who will take me out of this table? It's like those they do it in Nigeria movie a lot. Somebody will die and the spirit will be hovering around. Who will help him? My soul is not resting in peace, just like that. So it kept going until he met that kind. I think it was 1389 that now ripped it off the process table. That is orphan process for you. Now, before I tell you why we should avoid that, let's demonstrate zombie process. I just showed you. Let's demonstrate that orphan process happens when the parent process finishes before the child process. It happens, and the child process will be looking for a parent to rip it off the process table, right? By the way, lists. Let me tell you right now, so that that I remember. This process table is limited. It's finite. It has a definite number of processes that can be contained on this table, right? So if you don't control certain things, and this table gets full, it means you can no more process will run on your system. That's why if you're building your simple shell, you want to build something that will not create orphan process or zombie process, or memory leakages. Otherwise, it will affect the operating system itself, the entire computer. This is system calls you're making. So zombie process now. Zombie process. I said is when the child process finishes while the parent is still running, right? So let's go and change that delay that we have there. I will come here. I will make this full. Make this full, and I will go into that file. So I will change the sleep for this one now to 5. The child should sleep for 5 seconds. Then the parent should sleep for 10 seconds, just so that the child will execute before the parents. Right? Alright. I will save this. I will exit because I want to use both terminals. I will clear it and I will take it back to be small as it used to be. Alright, and I will clear this other place. Now this time I don't want to use the PS EAF anymore because I'm not targeting parent ID and PPID. I am targeting, I want full details, right? Remember, F for full format listing. Sorry, U for that. U for detailed information, right? So if I go A, all processes, no matter the user, then detailed, and then show me what is happening in the background as well. Okay, all right. If I do this now, it will show me the state. Remember the status of the running program. Okay, so this is how we. Let me filter as well. I'm going to filter. Add an instruction for you to filter what is happening. Every process that has a string or has a name process in it, and I think, have I compiled that thing? Did I compile it? I remember. You stop misbehaving. If I compile it, let me compile it again. Okay, so clear. Stop misbehaving. Okay. Are we good to go? And let's run. I'll run it. Maybe I will go here and run it once. Come again. Waiting for it to execute. I'll run it again. Hey! Run the command again. That was fast. Alright. So the child executed, right? And the child met the parents. Now the child says, I am with this PID 9720. My parent is 9719. The parents say yes, I'm the 9719, and my parent is 8598. Remember, 8598 is this very bash that's running here. Okay, now let's look at the process table and see something. I intentionally did it twice as well for you to see the status. Now it's record of two processes, right? That is 9719, that is 9720. Who was 719? Let me remind you again. 719 was the parent, 720 was the child. Alright, now let's go back to this place. Make it large again. I'll beat you. So 9719 was the parent, 9720 was the child. Now at this point, when I run it the first time, remember the child was sleeping. That's the reason for this X, and the plus means he was sleeping on the terminal, on the foreground, not in the background. And the parents of course was sleeping as well. He made it to sleep. And then 5 seconds later, I ran this command again to find out that this guy was not sleeping again. It is now in Z. That Z stands for zombie. It's now in zombie state. And at the point where I ran that command, the parent was still sleeping. He was still executing like a script. You can see this one has finished. So zombie, why is it zombie? Zombie because it has finished executing, and we need to make sure that as soon as the child finishes executing, it gets back to the parents. Listen, that's why I'm using the word die. It was given birth to, and from the very second, smallest split of second that it was given birth to, it was given birth to walk and die. Walk and die. So it died and was hovering over the place. It died and was just there, waiting for the parents to come and bury the dead body. Okay, that may not be technical, but actually when I say it died, I think die is technical. It died, the process died. Yeah, the process died, and the parent was not available to rip it off the process table. So it was busy doing something else, and later it came back to take the zombie out. If I check now, it's gone. It's no more running, so you won't see it there. You will see it there. This one you see here is the command I ran just now. You see, that's interesting, right? So you want to avoid zombie process. You also want to avoid orphan process. That's the reason for the wait system call. What a way to introduce wait system call. So the need for wait system call and how it works. I just told you the need for it. So as for how it works, let's find out how it works. Let's find out how it works. All right. I'm going to clear the screen and open the manual. Is it man to wait or man wait right now? Man wait, it tells us that we need to include this header, which is already there, and we need to include another one, sys/wait, and we'll do that shortly. Then it says it returns this kind of data type. We understand this already, and it takes one argument, w status. Now let's read about what that is. This is the prototype for another one for wait PID and wait ID, right? This is something else. Let's dealing with this one now. Wait. Okay. Description. All of these system calls are used to wait for state changes. Mark not the word state changes in a child of the calling process. So the process that called that child, right? The process that calls the wait. The process that calls the wait. Wait will now find the child of that that particular process that called a child, that particular parent that called the wait. It will now go and look for the child of that parent, right? And then look for state changes, right? Let's read on. And obtain information about the child whose state has changed. A state change is considered to be, look at this, the child terminated, the child was stopped by a signal, or the child resumed, right, by a signal. Let me take this on my board, right? Okay. So I don't want to type long grammar. I think I should use the Zenboard. No, I don't want to draw a new box again, new text box. I will take from here, so I don't get something too big. So talking about state changes. Don't worry, I'm going to code that. In our next session, we'll be writing a simple shell. I believe we should write a simple shell. Okay. State changes, and then we say the state changes is either when the child is let's say termination of child process, termination, or let's say when child process, when child is terminated. Let me call that number one. And number two, when child is stopped by a signal. Number three is when the child is resumed by a signal. Alright. So when you call the wait, okay, let me use this example here now. If there was wait call, if we check, okay, this will not give us a good example though. Okay, it will not give us a good example because we need to specify which one is the parent and there are no checks here. We're not checking for the return value of 0, PID, or -1, so it won't make a good example. But what you're saying in essence is that when you call wait inside a process, let me use diagrams, right? As a parent process, and there's another process running inside the child process. When you call wait in this very parent process, that wait will now make this parent to hold on and be listening for state changes. So the state changes is either of these three. If the child terminates immediately, without wasting time, immediately the parent just start running. So there's no space for zombie state. Immediately. And there's no space there's no time for both to run concurrently, like we saw here. we sort both program running concurrently. Remember, where one printed I am the child, one printed I am the parents. They are dragging space, you know. So it will not allow this to happen. It will make this is where the parent will wait for the child, which is the right thing to do for a program to run, the safest thing to do, you know, program to run without causing any wahala, any trouble, right? So if a signal stops it as well, something happens here and it stops, this sound, it will trigger the parent will just continue. The parent will immediately rip the child off the table and continue and do something. If it's written by a signal, something happens as well. In our case, we are looking at it terminating, right? So if it gets terminated, the parents start running. No space for zombie. No space for zombie. Okay, that's the only way we can control it because there's no other way we can have that control. And it's interesting. Let's look at the. Okay, let's read some more, right? In the case of a terminated child, performing a wait allows the system to release the resources associated with the child. That means whatever, if the child took space to do what it wanted to do, or took some memory or address or what, it will release it because it was terminated. Then if a wait is not performed, then the terminated child remains in a zombie state. You see now that I did not make the zombie up. I'm actually seeing this for the first time in the manual. I've read things about it. Zombie. Yeah, this is actually the first time I'm reading with manual. That's interesting. I've read documents about it anyway. So if a child, and I've seen videos about it, yeah, even the one by Jesse from Just Inspired. So if a child has already changed state, then this calls return immediately. Otherwise, let me not confuse anybody now. Some further. Let's look at the return value. Return value, wait on success returns the ID process of the terminated child. On error, it returns -1. Right? So this is how you have to check whether error happened. Okay. Excuse me. Now, where does this save? Okay. I think I want to read about that first argument. Is there no way they wrote about it? W status. Okay, I'm not seeing where they wrote about it, but what it does is it's an integer. It's an integer, so you just need to give it this pointer or the address of an integer. So it will go and save the state, the status of the child inside that integer, right? It will go and save. What I mean is this. Of course, you can choose not to give it anything, any integer. You can just give it null when you're not interested in the status, and it will work as well. Let's go and code now. Enough of the talking. Let's do some coding. Nano. Should I continue with the same process? I think I should continue with it. Would this confuse anybody? What do you say? Should I continue with this file or write a new file? Those of you watching live. Okay. Okay. I think I'll just duplicate this one. And please, wherever you're watching from, if by now you have not liked the video, what are you waiting for now? Like the video. If you watch this establish your learning, like the video. Don't be liking it in your mind and be admiring my work in your mind. Do something. Put some comments to show me how helpful it was. Ask questions if you found any part confusing, and do subscribe, please, if you are yet to subscribe. Come on, let's interact. Let me know that I'm making impact. Let me know whether I need to adjust somewhere, so that I'll serve you better. So I'm going to call this one using wait dot c. Okay. Alright, so let's work with using wait. If you're watching on YouTube, the link to the repository, you'll find it in the description. So you can go and play with these codes later on. And the link to the whiteboard as well, you'll find it in the video description. Now let's add the wait system call. Remember, we're supposed to, they said they use two header files. One is already there, so let's include the other one. I like to keep it close to this one so they look like twins. Include sys/wait dot h. Interesting. Okay, so if this is the parent light, right? So let's take off the sleep. If we make it wait and make it sleep again, we'll still create zombie states, right? So let's ask it to wait first. Wait. So you could pass null as the argument to wait. So that way, even if you ask, of course, I will still let it sleep so that we can monitor the process table, right? I will still let it sleep. Let it sleep. I can see, but you will see that for putting the child to sleep, the parent will be sleeping when the child is sleeping because of this wait. No, I would not ask the parent to sleep. It will join the child in the sleep and be waiting. Once the child status changed, once it gets terminated, or when something stops it, signal stops it, the parent is triggered to immediately continuous action. So, but if you don't want to pass null to this guy, if you want to catch the status, you need to declare an integer up here. Let's have an integer declare here. Integer. So int, you can call it anything you want to call it, anything that is not a keyword in C. So I like to call it status, but just to know that this is a variable. Is a variable. Let me call it outcome. Now this doesn't look like a fine name. Okay, don't use this name. You can use status or something, but I just want to show you that you can call it anything you want to call it. So long as that thing is not a keyword in C, it should work. So outcome. Now I'm not going to, this thing takes a pointer, okay? So I'm not going to pass outcome to it like that. I'll pass ampersand outcome. Just like if I had a pointer declared here, and let's say a pointer of type int declared here. Let's say pointer, let's say wait. Wait starts. I'm call it wait starts, and I say it's not equal to ampersand outcome. If I do this, then I can go and pass that wait start, that w start. I can go and pass it here, and there'll be no problem. W start. Now this is where the knowledge of pointer comes in. If that's confusing, I'm going to take it off. Okay, if that's confusing, but I encourage you to go and watch. Where's that guy now? Video on pointers. So you will find, check my playlist, click on playlist, you will find the video, the playlist named the part to see. Yes, open the part to see, and you will see I talk about pointers, arrays, and strings. Part 1 and 2. Also, this episode is part 3. So part 1 and 2, I explain this stuff, in a way, very simple way that even if it's your first time, you would understand. Especially if you work with the command line, you will understand. If you don't work with the command line as well, you will still understand. Alright, so let me take this off so I don't end up confusing anyone. Let's just go. Okay, let's just make this let's make things simple. You can play with your own code, okay? let me be a little bit conventional. A little bit. So I'll call this status. Status. And I will go here to the width that I called and say ampersand status. Okay, so it will go there. It will now that it's acting like a pointer, it has the address of that variable. It will go there and save inside it the status of the child of this calling process. Calling. Okay, let's now go and run our file and check what happened. And that might be the end for today. Would you like me to talk about exec-v now? Post a comment, or should I allow you to go and rest and think about this one first? Put in the comment section. Should I talk about exec-v? Or should I hold on so that you breathe in and breathe out and digest this one? And then we'll do it in the next section. So I'm closing this file. Let's run it. Or we need to compile it. So GCC, using this to see how we call the output with, we compiled without error. Now let's have this thing like this again. I will come here. I am ready to run the wait. And before I run it, let me go and put my command here. px. Okay, I used to have that command here. It's not been long. I use it. So that's it, right? Okay. So here I will run the wait. Here I will run this command. I run the wrong command. Sorry, because I'm filtering process. No, I'm supposed to be filtering wait. So we'll do that again. So let's do this and move this process and say filter wait. Okay, but now you see that everything is fine, right? Everything is fine. You says the child is 9897 and the parent is 9896, and the parent say yes, I am 9896 and my parent is 8598. Don't forget that 8598, if you do echo $, that is the PID of the parent indeed, which is the bash program that is running here. Okay, I'm going to clear the screen. I'm going to be ready to run it again, and I'll go here. I'm ready to run this command, so I'll go and then I'll run this command, and then I'm waiting. So there was no time to even catch it the second time. If I run this command many times, the same result will happen. Let's see what happened. First of all, let's take note of the PID. This one is 9909. The PID will keep changing, right? And this one is 9908. The parent is 9908 and the child is 9909. Okay, let's look at this. I don't want you, stay there. Don't be stubborn. And I make me forget the PID now. That 9908 for the parent, 9909 for the child, right? So 9908 was sleeping because 9909 was sleeping. That 5 seconds that the child was sleeping, the parent has to sleep because the parent has that's the instruction, that's the wait system call. So it will not do anything until this one changes its state. So when this one stops sleeping and executed, it immediately executed. So there's no space for zombie. Let me run this command multiple times. Like I will run the program and run that command multiple times. So let me put the command on the screen here. Let's put the program here. So we run it run the program once, run the command again second time, run it the third time, run it the fourth time. Oh, the fourth one has even finished. So let's see. The first time that I ran it, first of all, let's check the process ID. You know, the process ID will always change. The reason why this one is not changing, I told you before, right, is because it is the same bash. It has not changed. It's the same instance of bash. But this one, if you run it 10 times, the PID will change 10 times. So this one now, the parent is 9925 and the child is 9926. So let's go and work with let's go and see 9925 and 9926 on this table. So first time we have 9925 sleeping, and 9926 his parents was sleeping with it. Second time around it, we have 9925, he was still asleep, the parents was still asleep. And the third time, they are not there again. They are not there again. You are out, they are off. You see, that's how the process table works. Everything that has stopped running will not be found on the process table again. You see? So that's it about zombie orphan process and zombie process, right? Or zombie state rather. I think zombie state sounds even more accurate. Zombie state. So I've talked about the need for wait and how to use it. Now, what does exec v do? Did you see I should talk about exec v? In the comments. You know what? Okay, I'll just act like I want to introduce it and then leave you. What exec v does? Let me just do whiteboarding. Not coding today. What exec v does is this. I think I just need for a new whiteboard. A new what now? A new space or what? A new sheet, a new slide, whatever. Exec v. There are different prototypes or different types of these. Our focus is exec v for now for this section. What it does is, I think I'm still going to use Zenboard. Yeah. What exec v does is, since this system call fork system call duplicates, creates an identical copy of exactly what the parents has, exec v now comes, right? Exec v what exec v now does is to go here and overwrite everything that is here. That means this case that we will be having a terminal where both of them are printing the same thing, it will not be the case here. So if exec v was inside this child, it will not make the child print, it will make the child not print this and the child. Like if, okay, this is not a perfect example because they had different instructions here, but this on the whiteboard is a perfect example where they had the same instructions. Okay, so this one will come here and overwrite everything here. In fact, it will do something, whether it's the same instructions or different instructions, it will take everything, it will overwrite it and say, I am the organ now. And this XV executes binary. What are binary files? Binary files are those files that are executable. When you do GCC, this, the a.art that comes out, or whatever files you name it, that green one is the binary. And I've told you before, those are the things that are running in this system. The ls I showed you, I said it in the section 1, right? I showed you that, in section 1. They are just binary files. So do you get it now that when you're trying to write a simple shell, what you're trying to achieve, brothers and sisters, is to write something, a program that prints a prompt. It prints a prompt. In this case, they just want to print only $, right? It prints a prompt and it's able to take in command. So when I give it ls to your program, to your shell that you're writing, it should go with the help of exec v. First of all, you don't want to kill this process. So this process has to create a child process that will go and run this ls. And the child process will have to call exec v so that the child process will not come and start printing prompts like this. Because you're creating the child process with a fork system call. Okay, and so after creating the child process with that system call, you want to make sure that you overwrite everything so that the child process will not go and become an identical copy of the parent. It now has its own instruction. So with exec v will go and pick ls or where it is from that bin where it is and execute it. After running it, that child process will die and come back to this process, and your loop will print again. So it executes it, you know, it's it's it it's okay. Let me yeah, this technical term just came to my mind. It reads the line, it executes it, and then I'm missing one, prints the loop. I'm missing one. Somebody remind me. If you remind me, post the comment. Comment. It's just going to teach me now. It's something that goes like this. Read, execute. That's something before print loop. Is it REPL? Aha! REPL. I think this is it. It reads, it executes it, it prints, and then it loops. So when I did ls, it read what ls is. No, it executed it, and then it printed, and then it looped. Your shell should be able to do like this. Now, before the next section, you already have an idea of what you want to do, right? We want to write a program that when that program is running, you know, and someone types a command like, hey, you've got to come to you go back 5 login now. Alright, and you type a command like ls, let's say pwd. So you type in pwd, this guy cannot go and do it by himself, otherwise it will die. So the way you do it is to create a child process. Alright, so it's the child process that will what do I do now? How do I bring that guy forward? You come forward. So it's the child process that will now go and execute the pwd. So it will now perform it will now call this one. Okay, the question now comes, which one will read the line? Which one will, because you know that once you call exec v inside here, it will not allow anything to run again. It will call a binary, and that binary will become the Oga, the landlord of the program. It will overwrite everything. So it means that inside this one, that is your bash, you will read the line. Inside this one, you will tokenize and break them into pieces, and check. Inside this one, you will check whether it's a valid command. You know, inside this one, you will, if it's a valid command, you will go ahead and now create a child process that will go and call execv, and execv will go into the binary of that computer system and call that program, and the program will run. When the program is finished running, the program will run, and then this guy will die and return to your bash, your shell, and your shell will now print a loop waiting to read another command, or waiting to get the EOF signal for it to stop. EOF, I've mentioned that several times. I encourage you, spend your time, invest your time in these videos. Invest your time in these videos, and you can of course you can watch others as well. You can read documents as well. I'm not saying you should depend on me, but I just know that I really have a way of doing this thing, such that even newbies, even the confused, will learn. So pay attention. Let me help you in every way I can. Don't restrict my help to you. Okay, please read. If you have any question, please post as a comment later on the video. You can, yeah, if you're watching on YouTube as well, post your question as a comment. You can reach out to me. Click on the about of this channel. You can actually reach out to me directly. I am very, very reachable. I'm on LinkedIn. You can follow me. You can connect with me. I'm on Twitter. I'm on GitHub. If you like Facebook as well, I'm there. In fact, if you like TikTok, I'm there. The same username. The username is this. Just do what you like this. If you've not liked this video, you're wrong. If in case you downloaded it and you're watching it somewhere, come back to YouTube and like it, share, and then make sure you're subscribed. Okay, that's my username on social media platforms. All social media platforms except Instagram. I'm not even very active on Instagram. All right. For now, I'm going to say thank you for being part of this section. Do all you could. I want to thank all of you who do do those little things that encourage me. Like amazing. I sometimes I used to feel like stopping. Seriously, I felt like let me just end this thing. But ah, when I read some feedback, somebody came. Let me not even say it here. I'm live. But it was encouraging. I was encouraged. So I had to continue. So we are in this together, right? Let's do hard things. Let's keep moving. Thank you and see you in the next section. Bye bye.